Good morning. Today my topic is master slave flip-flop. Contents: master slave flip-flop, metastability and setup time. First we can see master slave flip-flop, what will happen here. Okay, this was the circuit of master slave flip-flop. Here I can use two past transistors T1 and T2 and also two memories I can use here. Okay, let me enter into operation. While I am giving in clock 0, clock 1, what will happen, it will see. Now I am giving clock as a clock signal clock 0. I am giving clock 0 here. That clock 0 it will inverted into clock 1. Why? We are here we connected into inverter, that's why it will inverted 0 to 1. Again here also one inverter will see. Again this inverter will inverted into 1 to 0. Here we'll see this is the clock signal, this is the clock 1, this was the clock 2. Here I am giving to the 0 low signal. Low means clock 1 means clock 1 1, clock 2 means 0. All of us know this was the P transistor, this was the N transistor. If we are giving 0 means P transistor is on condition. If we are giving clock 1 has 1 means NMOS transistor is on. So totally this pass transistor will on condition. Here we are giving clock 0. Clock 0 means low. Low signal T1 will on. Now you will understand how it's on condition while we are giving in clock 0. Here my desired input is 0. I have moved from 1 to 0. So initially it was 1. This 1 is here because clock is low. The pass transistor is moved to the right side. And 1 bar and 1 bar which is 0 is moved to the this node. Move to this node. This is the main node. CMOS transistor. Here it has not successfully. Now you are at 0 at CMOS transistor till this point. So this pass transistor is on. This one will discharge this capacitor completely to 0 volts. Whenever you give to 0 to this inverter will charge at this capacitor completely 1. So all fine up to here. The transistor from 1 to 0, I am doing exactly when clock is also changing. So what I will happen at this time, clock is trending towards to off condition is when clock is equals to 1. When clock is equals to 1, that pass transistor is off condition. How? Let us see. Clock 1. Here I will give clock 1 here. Clock 1. Here I connected to inverter. Clock 1 it will inverted into clock 0. Clock 0 again inverted into clock 1. Okay. Clock 1 means 0. Clock 2 means 1. What will happen? Clock 0 means here NMOS transistor. NMOS transistor 0 means off condition. Clock 1. Clock 1 PMOS transistor it will off condition. So the pass transistor is totally off condition. When clock is tending to 1, what is happening to pass transistor T1 when it is tending towards to off to the clock? So whenever the clock is going from 0 to 1, this pass transistor is trying to get off condition. Here clock I am giving high. High means T1 pass transistor is off. How? Already I explained here. Before the clock is rising to 1, before this fellow is switching off. So only some voltage is moved here. It is not able to discharge entire 0. Discharging into 0 means from 1.8 volts you need to go to 0. All of us know this point. Because your clock went high and you do not have enough time. We don't have enough time here. It has discharging only 2.9 volts. That's why we are not able to discharge also. Now we are understanding how the master and slave flip-flop it will operate. While we are giving clock 0, what will happen? While we are giving clock 1, what will happen? Understood all of us? So this is the master, this is the slave. Whenever we are giving in clock 0 means low signal. The T1 pass transistor is on condition. The T2 pass transistor is off condition. Why? Clock means 0. 0 means NMOS transistor is off condition. Clock 2, clock 1, 1. 1 means PMOS is off condition. Okay. While we are in high clock means the T1 pass transistor is off condition. T2 pass transistor is on condition. This was the totally master and slave flip-flop. Okay, we'll enter into waveforms. Waveform. This was the clock signal. This is the clock signal. We know that this is the input signal. This is the output. Will getting that output signal. If low means 0. 0 means what will happen? The master flip-flop is on. The T1 pass transistor is 0 means on. It enters 0 to 1 means it will getting half stage. That rising edge. It high. High also it will switch off. T1 pass transistor is off condition. T2 pass transistor is tending to the on condition. It's a falling edge and means 0 to 1. 1 to falling edge means 1 to 0. 0 means that master is on condition. This is the input signal. This is the clock signal. 0 means low. It's 0 to 1. Here 1 is 0 to 1. It's a rising edge. This was the high transition. This is the falling 1 to 0. It's fall down. That's why it is a falling edge. This was the totally up to here. This was totally one cycle. This is the rising edge, falling edge, high transition and low. Now we'll see metastability what will happen. This is the metastability circuit diagram. Here I am giving this was the clock signal. This was the input signal. Here I am giving clock signal and input signal. Clock signal, here it will start. Input signal, here it will start. I am trying to transition the input before rising edge of the rising edge of the clock. This one was not able to charge. Why? You have given a limited time to this mode to charge. So much more time you are not giving. That's why this capacitor was not fully charged. This point nodes and they switched off. We switched off this pass transistor. Now this inverter seeing only 0.9 volts only. The inverter doesn't know what I should do with this. It will give it later. It might go to 0 or it might go to 1. So it might go to extend. This is called as a metastability. Here we give only limited time to charge this capacitor. We don't have give to that more time. This will charge only 0.9 volts. That time the inverter was confused. What will happen? I'm going to 0 or 1. That confusion state is called as a metastability. We are not confirmed. It's either 0 or 1. That time it is called as a metastability. We'll see setup time. This was the setup time diagram I'm explaining here. Okay, Here to here will enter. Will enter a train bus. Before we are waiting here. Okay, let will see it will come. Here it will not able. So what is the definition of the setup time means? Before rising before rising edge of the clock, the data should be stable is called as a setup time. Before rising the edge, this is the rising 0 to 1 rising. Before rising the edge of the clock, the data should be stable. The data should be stable is called as a setup time. Thank you. This is the master and slave flip-flop totally. I hope understood. Thank you.